So we have two downloadable papers that I've gathered off the internet, so to speak. They're for continuing education units for architects. One is on sustainability, the idea of life cycle analysis of the steel, recyclability, how green it is. And the other one that we're going to cover right away here is the idea about architecturally exposed structural steel. And this really kind of gets into the idea of rating systems. I've already presented part of this in the slides that I've shown you, but we'll go into a little more detail. You'll be required to read these, and then we'll have a little quiz on the next module. So let's start with some of the ideas here. Here we have obviously a beautiful interior with exposed structural steel, and the question is, okay, so we're done here. But in fact, there's a lot of pre-work that the architect needs to understand. Structural steel that isn't going to be exposed coming from the mill has blemishes, finishes, requirements that are not necessarily at the expectations that the architect may have if it's going to be seen in the interior. So if we're obviously a steel beam can be rusted, its coating system, if it was painted for rust resistant, could have defects in it. All of those things could be fine if they were going to be covered with fireproofing like drywall and or in a ceiling cavity. But when we want to expose them, and this is the primary kind of discussion about this, what we're going to talk about is that when we expose them, we need to be able to specify to the contractor, to the fabricator, the kind of appearances that we want. We need to be able to have a common platform for that kind of dialogue and specification. So just another example that's in that presentation. I thought it was really quite nice. Here we have a roof structure. And once again, we have that mix of wood and steel. It's kind of hybrid mixing of materials, possibly being that using the one that performs the best in whatever given application. I throw that out because there's a lot of talk about making things completely out of wood. And I think that the dialogue is much more dynamic about that, especially when we're talking about, we might reach to the idea that an all-wood structure is the greenest, but in fact it may not be true because of the amount of timber or the effects or the environmental impact that it has. It maybe hasn't been discovered yet. Maybe will become apparent that we're overforesting or whatever. You can see many different scenarios where that idea about carbon footprint could change or evolve over the coming years. And so I want you to keep in mind this idea of hybrid design, these kind of materials coming together, and each one doing the best job that they can. Another nice thing about this image is the way the steel structure is expressed, and this could also be done in wood. This is not specific to steel, but here we have the last steel beam that comes along this assembly of the roof structure, and you'll notice that it's almost half the size of the interior beams. And in a way that makes sense because on the interior beams, the tributary load is coming to both sides of those beams. When we're the last element to support a floor system or a roof system, the loads are much lower because we're only taking the tributary loads from half of that section. So therefore, they were able to thin that down. And the associated cantilevered beams that are supporting that final beam are actually tapering. So you can see how they get smaller here. So there's a lot of really kind of attractive things visually happening here to make the outside edge of this appear to be thinner and more lightweight. On the interior, so here we have what may be structural columns. They actually appear because we're supporting these large glass wall systems, exposed structural steel. And introducing this idea of lighting, you'll notice that they're lit up from the floor. And this can be a caution to you right away that steel or surfaces that appear monolithic and very clean in normal diffuse lighting, which you'll find in the interior, can really show up its scars and blemishes when they're heavily side lit like this. Needless to say, that's not the whole point of this image. Obviously, this is a great way to create both an elegant and beautiful structural system as a kind of feature entry to a building. Once again, back to that discussion about like tectonics, connection systems. Here we have a riveted assembly. The idea is that there's no welding happening here. These two components are brought together and rivets are transferring the load from one element to the other. This is part of that presentation, and what they discuss about here is this is covered with intumescent paint. And you'll notice that it really doesn't, you don't know this to be coated with a material that is actually fireproofing. It just looks to be a paint applied to that surface. And once again, that idea of what intumescent paint is, that idea of swelling. So we're, if we look over here at where the 5 is, that's an I-beam with intumescent paint on it. And then that kind of massive expansion of that material when exposed to heat. So that idea of aesthetics, tectonics. So just to compare and contrast here, on the left-hand side, we have what looks like a baseball stadium. And probably the architect's intent here was to create kind of a nostalgic, historic look to its construction. So we have things that harken back to kind of historical steel construction. We have truss systems, trying to do the work of maybe our lack of being able to fabricate larger components at that time or manipulate them. We have riveted connections, where we're very popular in the early part of the 20th century. Mostly because of the lack of sophistication in our ability to field weld strong connections. But as we advanced, we were able to create either sub-assemblies, large sub-assemblies, and to be able to field weld. And so the aesthetics of our assemblies changed. And this kind of represented, partially represented, in this kind of other expression of steel coming together in a much more modern, cleaner aesthetic. But obviously these are part of the range of the palette that is available to the architect in design. Just another cool shot of exposed structural steel, the bolted connections, this kind of really heavy webbed truss structural systems, possibly even oversized to create more of a sense of scale and excitement and intensity of the project. So there may be more steel here than's actually required for the project. Another example of exposed structural steel in an interior application. A lot of these are somewhat what we'll call built-up sections. So these adaptive columns that are carrying the load, notice the taper on them. So these are cut out of flat stock to the curve shape, and then the flanges are welded to the outside edges. So these are completely, shop fabricated and then brought to the site. Creating a really beautiful aesthetic. So a little more about that idea that I said before about what a fabricator might see as a good-looking piece of steel compared to what an architect might think about. So here we have on the left what would be a steel beam, even arriving for use on the site. That splatter, those little beads up there, are actually spatter from the cutting of this W section. So once again, as I discussed, the way this section is cut is we have 3 bolt holes to transfer the shear load to what will probably be the column. But we have the flanges, the bottom and top flanges, cut well back of what will be the column or its intersection with the column. And that's so that this beam doesn't transfer the moment, the twisting forces of its deflection to the vertical column. But with that, the fabricator flame cut these using a torch, probably on a CNC torch machine, that precisely cut these shapes out. And when it does that, there is this kind of spatter of the molten metal. And while these are fine to tolerance to bolt together, they've created both an ugly edge here up on the top and also this weld spatter along the surface. And if you didn't specify that this needed to be removed, cleaned of weld spatter, and the edges ground to remove any kind of fabrication, defects like this, you'd get a painted piece with all of this kind of crud stuck to it. Now, in some applications, that might be perfectly acceptable, but it might be that your attitude is more like what is on the right-hand side here, where you have this really clean surface that's painted and people can see it. And then once again, notice something that might surprise you, that kind of indication of what that steel beam is with the engraved part number on it. And here's just another example of that raised up. And I don't think I would consider that unacceptable or even an aesthetic issue, but you might be surprised by it in your first time and find that to be maybe an unacceptable or an unpleasant surprise. There's discussion in this sheet that you'll read about the welding and finishing welding of the components. So here we have two, we have this idea of these structural crosses, very much about a design aesthetic. The architect probably wanted these crossing instead of just being diagonal truss-like elements. And in that case, these two intersecting pieces of steel had to be joined to each other. These aren't available off the shelf as X's. They're not fabricated. They're just tubular steel. And so if you look above my head here on the right-hand side, you can see this hinting of where that weld, that joinery. So this is the full solid piece going from top to bottom here. And then these transverse elements here are welded in. So this is an individual element, and on this side it's an individual element. And in order to make these look monolithic, this was fillet welded, and then the fillet weld was ground down until it was flush to the surface. So the overall appearance, if we look down the hallway here, is that these are really very pristine looking monolithic objects. But on close inspection under certain light, you will see this kind of a defect. I think that could be considered to be perfectly acceptable. This is a really heavy steel kind of structure, fine and passable. And actually, you would actually commend the fabricator for doing such good quality work with that fabrication. But it still may be a surprise to you that kind of detail shows through when you expected them to look completely clean to each other. And that gets on to another idea. There is a chart I'll show you next about this idea about how close you are to something and then what level of quality it has. So here we have this beautiful structural steel facade, and we have things that are very close where the eye makes contact. So we have this pinned connection at the bottom of this assembly, and the quality of that finish of that element, because it's very close to us, we can see it very easily, needs to be higher than things that are further away. So this idea of decreasing level of specification depending how far the viewer is from that element. One of the things I wanted to note, I made a little red arrow here. Let's see, it's pointing at the HVAC ductwork up here, and I kind of find it remarkable, and probably maybe to the discontent of the architects, to think that they went through all of the trouble to create these nice, beautiful curving surfaces, and then one of the final elements, kind of like to actually juxtapose that curve, are these straight pieces of HVAC ductwork. I'm sure that it would be very difficult to think about fabricating that ductwork in a curved form, but it really does kind of visually detract from that idea of this beautiful curving surface. So unexpected maybe results in the project, and maybe this is the kind of thing that's caught in this idea of BIM modeling, where we are actually putting all of our components together at one time, so we're all aware of kind of the effects of things like that. So here's this is a chart. I really, it's not that we're going to memorize a chart, but the idea that this shows you that there are the ideas about how things need to look. So here we have that highest level of 4, where we have once again that that column system that I showed you at the entry condition with that apparent, with that strong side lighting. And so the quality of the finish needs to be very high. Two things that are the least critical about the way things look in the case of the basic level of exposed structural steel. Still making sure that grease and weld and oil spatter is removed. Rough surfaces are deburred. The appearance of the fillet can be important. Bolt heads and connections are the same size, kind of a uniformity with each other. All of those things can be specified. And these are just kind of field guides. I think that in the discussion, you might say this as a 1, but there may be allowances made for issues with fabricators or other things. So these are, not necessarily charts that you need to become expert at now, but you need to remember that existence of different levels of specification of that finish. And the reason you do, and why you don't specify everything to be finished as best as possible, is because there's many times extreme cost involved in this kind of level of finish to the steelwork. and it may be unanticipated at the first level of quoting on things, or you're taking estimates of steel as you would have with structure. And now when you're specifying them to be exposed, the amount of secondary operations that need to happen to the steel to make it look the way you want it to add a great deal of cost, and that needs to be anticipated, and that level of quality needs to be able to be communicated. So here we have a beautiful interior column. Looks like welded together here. My head scratcher is how did they get this into this building? Was this the first thing on the site or not? Just another just beautiful structure. The kind of thing that I'm hoping we'll be able to do in some of our later computational design activities within this course. And this is a nice kind of a tectonic, once again, showing the nuts and bolts and the connections. So here we have a pin connection, major amount of structural components coming together. The idea that they're all either acting in tension or compression with each other, and we're really trying to deliver just those forces to our elements here. So we pin that connection together. The way of a lot of forces are coming into that pin, and we're distributing those shear forces with each one of these little flanges that we have on here. And so there's multiple ones of that just to distribute that shear force across that pin. But it then becomes a beautiful expression of the way forces are being transferred, and I guess that kind of meeting of the idea of, oh, well, tectonics, what is this really, this could have been architecturally decided that you didn't want to see all of this, and this could have been covered with a plastic cover that just made it look like it was just a blob, so to speak, at that corner. And that could be fine. Those were the aesthetic intentions. But this is also kind of a reach about that. If you understand these aesthetics and you understand how they'll play out in your buildings, you can decide that they're actually contributing instead of detracting from things. And not to get overblown, architecturally exposed structural steel is all over the place. So here we have some covering for train, a train loading or transfer station of exposed structural steel and truss systems. And so that pretty much covers just that idea of the kind of aesthetics of the exposure of steel. And next we're going to get into that idea about kind of their greenness or their carbon footprint.